हेलो चिल्ड्रन। आज हम बात करेंगे मोमेंट ऑफ अ फोर्स। मोमेंट ऑफ अ फोर्स ये कंसेप्ट किसके लिए है? दैट इज रिक्वायर्ड टू बी अंडरस्टूड एज व्हेन वी अप्लाई फोर्स then there will be translational motion in the object. Similarly, for rotational motion of an object about any axis, what is required? That is torque. So let's understand the concept of torque. Suppose this is an object and this object, three-dimensional object, is in one section of the object is considered जो कि इस प्लेन में है। ठीक है, अब इस जगह पर हमने एक कोऑर्डिनेट सिस्टम कंसीडर कर लिया है। ठीक है, यूं समझ लो कि दिस इज अ कोऑर्डिनेट सिस्टम, दिस इज द ओरिजिन and this is y axis and this is z axis। एक थ्री डायमेंशनल ऑब्जेक्ट है, हमने एक सेक्शन कंसीडर किया है। दिस पॉइंट इज कंसीडर्ड एज द ओरिजिन ऑफ दिस कोऑर्डिनेट सिस्टम। ठीक है, इफ वी कंसीडर एनी पॉइंट p over here, when a force F is applied in this direction and its position vector with respect to this coordinate system is r, then you see this force will try to rotate the object in this direction. If axis is over here, it will try to rotate. If the axis is fixed, this force will try to rotate, right? Rotation will be in this direction. So what is the torque? Torque is defined as, or moment of force, moment of force F is equal to R cross F vector. R is the position vector of this point P where the force F is applied, and of course F is the force applied, and this is denoted by moment of the force is denoted by a Greek letter, that is tau. Tau is equal to R cross F, and of course this is a vector quantity because there is cross product of this position vector and the force vector. It is the vector quantity. That is why this tau, moment of the force, is a vector quantity. Whenever there is vector quantity, means it has to have the magnitude as well as direction. तो इस tau का direction क्या होगा? And vector product I have already taught to you. So R cross F. See, direction of R is this. Suppose this angle is theta, right? So if we extend it back, so this will also be theta. So this can be written as, therefore magnitude of tau is equal to magnitude of position vector is R, this is F sine of theta, the angle between R vector and F vector. See, this is called the moment of the force, and this magnitude of tau is denoted by simply tau without putting arrow at the top, that is R sine theta into F, right? What is R sine theta? We will look at this. Suppose OP, we will write mod R is equal to R is equal to length OP, this length. So if we draw perpendicular from here on this, suppose this is M, OPM is right angle triangle. R sin theta is perpendicular on this F. OM is perpendicular on the line of action of this force. So we can say therefore tau is equal to r perpendicular f. We can write like this. This is the moment of a force which gives turning effect to the object. So we have understood what is the magnitude of the moment of the force, that is r perpendicular into f. R perpendicular means component of this along the direction perpendicular to the line of action of the force is called r perpendicular. Or we can say this can be written like this also, tau is equal to f sine theta into r. Means this is f perpendicular into r. F perpendicular into r means, see, if we put a perpendicular over here, component of this f along this is f sine theta, it is perpendicular to r. So this will be f sine theta. This is f perpendicular or into r. This is also f sine theta into r is the torque. It means f perpendicular into r or r perpendicular into f. Either way, this is the magnitude of the moment of force or torque. What is the direction of this? As we know, r cross f is equal to tau. Now tau is such a vector which is perpendicular to both r as well as f. Force and the position vector of the point P at which force is applied. So this torque is perpendicular to both. It means, you see, this r and f, in which plane it is? It is in xy plane. In this plane, in the plane of the board, this r and f is there. It means the tau, the moment of force or torque, will be perpendicular to this board. It means it will be either inside or outside. That is, axis will be, direction of this torque will be along z axis. That is the axis of its rotation. In this case, since anti-clockwise movement is there, so using right hand thumb rule, this type of motion is there, so direction of tau will be outside the board. So direction concept is clear, because direction of r cross f we have already studied. Direction of a cross b, it is perpendicular to both the vectors a and b. Similarly, the tau, direction of this will be perpendicular to r and f. So this way we have found the magnitude and direction of the movement of the force. If we take a few examples, I will take one example. Suppose position vector of the point P at which the force is applied, that is 2i plus 3j. 2i plus 3j, because I have taken the position vector in xy plane, that is plane of the board. Similarly, force F, it is also 4i plus 7j. Right? This is the force vector and the position vector of the point P at which force is applied. Then what is torque? So tau, we know r cross f. So we can write r is 2i plus 3j. It is, of course, it is unit vector. We should put cap at the top, right? And cross f is 4i plus 7j. We will take cross product, which we have already studied. So I cross I will be 0, j cross j will become 0. So we will write j cross I, that is 12j cross I. J cross I, and here plus 14. 7 into 2, that is 14i cross j. We know What is J cross I? J cross I is minus K. We know that is 12 into minus K plus 14 into K, unit vector along Z axis. So this will be how much? 2K. This tau vector is 2K and magnitude of tau will be 2. So it is very important. What do we notice? Once we have taken the position vector of the point P at which force is applied, जहां force लगाया गया है और जितना force लगाया गया है दोनों किस plane में है? I have taken IJ, components are taken I and J, में x axis and y axis. It means both the vectors are in xy plane. हमारा result क्या आ रहा है? 2K. This 2K means along Z axis, unit vector along Z axis. It means torque is acting perpendicular to both the vectors R and F, and since these are in xy plane, the torque will be acting along Z axis. So magnitude of torque is 2, so I will say torque is 2. Unit will be whatever unit is given. Unit of that will be force into distance, so Newton meter in SI unit and 9 centimeter in CGS unit. So this is the vector quantity, and magnitude of this is 2. So we will solve more problems later. Till then, all the best. Take care of you.